Good morning, students. Welcome back to the digital electronic class. So let us continue with the same discussion of unit 2. In that, what we discussed in the previous class, we talk about the multiplexer with its 2:1, 4:1 and 8:1 multiplexer we have discussed. And we have seen its complete block diagram, truth table, even though the designing part also we have seen. In today's class, we are going to do some problems based on the multiplexer. So let us see the problems based on the multiplexer. So they gave one question, implement f of x comma y comma z. So first question we are taking, so we do have implement f of x comma y comma z is equals to summation 1 to 6 7. So summation of 1 to 6 7 using 4:1 multiplexer. So we do have this question. So they gave one question, implement f of x comma y comma z using 4:1 multiplexer. They gave one value 1 to 6 7. So they gave these particular mean terms. We need to design this particular thing by using the 4:1 multiplexer. So basically, what is 4:1 multiplexer? 4:1 multiplexer is about, it has how many number of inputs? It should have 4 inputs. So this is 4:1. So 4 is nothing but 2 square. 2 square means it has 2 select inputs. So I'm just mentioning S0, S1. It has some inputs I0, I1, I2 and I3. So it has one output, right? This is your output O1. So they gave how many variables? It's what? 1, 2, 6, 7. So that means it's what? 0 to 7. That means it should have 3 variables inputs. So suppose I'm assuming those are inputs are x, y, z. These are my 3 inputs. What are the values of 3 input combination? So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 0 and 1, 1 and 1. So these are our input combinations. So we took the input combinations. Next criteria is that we need to write the output. So for writing the output, we need to decide, we need to select out of that what are the values. So first two I'm just making like this. Next I'm segregating this way so that I can write by looking into z. So what is the given value? So I do have output. This is nothing but mean term m1 plus mean term m2 plus m6 plus m7. I do have these numbers. So wherever it is there, that should be high. So where it is there, so what I can write for this, this is what, if I mention in terms of mean term, so this is m0, m1. Likewise I can write m2, then I do have m3. Next m4, m5. Next m6 and m7. So these are my inputs value. I just mentioned as it is. Now tell me what are the values. For m1 it should be high. For m1 it should be 1. Right? For next one m2 it should be high. For m2 it is 1. Like for m6 it should be 1. For m7 it should be 1. It is high, right? Because it's given that particular values, so we mention high. For remaining bits it is what? Low. So this is 0, this is 0, 0, 0. So we put all those values. Now so this is our functions, right? So what we are deciding, we are selecting. Suppose this is this particular value, I just want to select. Based upon these value, I need to write the output value. So when it is m1 is 1, z is also 1. What I'm doing, I'm just looking into z values. So similarly, when m1 is 1, z value is 0. So I'm selecting what? This is z, whatever z value is there, I'm assuming this is my select input. So how do I write this particular thing? I can write this way. So when you had 1, when you had z, for z value it is 1. For this particular part I'm saying, this for only this particular thing, this is equals to 1. For next part, if you see this particular combination, when it is 1, if I want to see only z, I can write this is nothing but z bar, right? Why I'm writing z bar? Because output is high when my z value is 0. I'm not looking into the remaining, these are varying. Only I'm looking into z, I'm assuming z is my select input. I'm selecting one particular input. So now tell me for the next value, when is high? When I do have what? This is what actually? This is z bar. Why z bar? Because z value is 0. So when it is high, when I am giving, this is z. So what I am doing, students, so we are taking Z as my select input. Based upon this input value, I am writing the respective output. So for mean term M1 it is Z, for mean term M2 it is Z bar, for mean term M6 it is Z bar, for mean term M7 it is Z. So based upon this Z value, I am writing the output. I just want to see X and Y are varying. So X and Y I am not looking into it, I am just looking into the Z value. So how do we design? So what are the things we did? We first make the 4:1 multiplexer, we took the mean terms. Second part of that would be by taking these values we mention. So we mention this by taking this particular value. Next thing is that we need to write the output for it. So see students, so what we did? So we took the values of all the mean terms and we find the functions for it. So what is the values we do have? When Z is equals to, when output is there for mean term M1, M2, M6, M7. So M1, M2, M6 and M7, so right? So now what I'm doing, this value I'm not taking, this is my, suppose this is select input X, this is my select input Y. What I'm doing, I am making 4:1 MUX. So in 4:1 MUX what I'm doing, so 4:1 multiplexer or MUX. So in that I do have I0, I1, I2, I3, right? I have 4 inputs. So these 4 inputs, how do I connect? So one select inputs I had, suppose X, another select input is Y. Now what is Z then? Z is based upon Z, we are writing the output function. So how do we write the output functions? So we wrote all the mean terms, right? Next thing what I am doing, I need to write the output value. How can I give these values? So for giving this value, what I am doing, I need to decide the Z factor. So what I'll do it, for this first one, for this particular value, I'll write it as Z, segregating to Z. For the next value I'm writing, it is Z bar. For the last one, it is Z and Z bar, both are there. So that one decided by this factor. So since here is 1, it is 0. Here is 1, it is also 1, right? So whenever we are having, this is what, this I can write it as Z bar. So this is I can write it as Z. What about this then? This is 0, nothing is there. And for this value, again it is 0, right? So what I can do it, I'll take first input combination. If I am giving, what is the first input value? If I do have the inputs value, what is I0 indicates? It indicates 2 values. What are those 2 values? 0 and 1 for the first function. So I am connecting, this is my Z. It consists of 0 and 1. Next input, it is what next input? 2 and 3. So for 2 and 3, what is the value I need to give? I need to give Z bar. Z bar in the sense, I need to take one NOT gate and I need to pass here. So this has become Z bar. For next input, combination I2. What is I2 value we are doing? So what we are doing, students, so we did the truth table for it. Next thing, we need to go for designing part. For designing this thing, what I am doing, I need to connect it. What I need to connect it? This function is the output, right? So when we had these ones, these values is what? For 1, we have 1, we put it. For 2, we had 1, we put it. For 6, we had 1. For 7 also we had 1, we wrote it. Next criteria is that we need to design the 4:1 multiplexer. It consists of how many inputs? 0, 1, 2, 3. So it is what 0 to 3, that is nothing but it should have 4 inputs. So we took 4 inputs. Next thing, I am assuming this X and Y is what actually? Suppose this is my select inputs. So in this I am assuming X and Y is my select inputs. So next thing, I need to write the output function for this particular situation. For that, what I'll write? So tell me, this is varying, right? So 0 and 1. One time it is 0 and another time it is 1. So I'll see only this one. So I can write this as Z, because when Z is there, it is high. So for I0, what I am writing, I am taking one Z. Directly I am passing. For the next, rest of 2. So when it is high, when we had Z bar. For these 2, I'll mention it is Z bar. How do I connect Z bar? I'll connect one NOT gate, I'll pass it, this has become Z bar. For rest of these 2, it is, both are 0, right? It is nothing but logic 0. So directly I'll give 0. Next, for rest of 2, I can take logic 1. So I'm connecting 1. So this is the way I designed. So what I did, students, I just based upon that. First thing, when Z is 1, it is high. So we'll not see this one. We only see this one. When output is 1, Z value is 1. So that means it is Z. Now for the next situation, when output is high, when Z is 0. 0 means it's Z bar. We will not look into this 0 value. Output 0 will not see. We'll see when his output is high, what is the value of Z. So Z value is 0. That means it is Z bar. Similarly, these 2 are zeros. So there is no Z value when there is no high. That means both are 0. It is logic 0. So when both is 1, then it is logic 1. So this is the way we took 4:1 multiplexer. We had these 4 inputs. First we gave Z. We are assuming this is our two select inputs. 2 inputs, not select input, it's 2 inputs. So that is nothing but I0, I1, I2, I3. Those I have mentioned like this. I do have X and Y. This is my select input. Z is the input combination. Based upon that, the multiplexer is going to produce the output. So this is the way we can go for 4:1 multiplexer. We'll see one more problem based upon 8:1 multiplexer. So students, we will take one more problem. We will take the second problem. This is our second problem. What is given? Implement the Boolean function. So they gave one Boolean function f of a comma b comma c comma d. A, B, C, D is equals to summation of 1, 3, 4, 11, 12, 1, 3, 4, 11, 12, 14, 11, 12, 13, 14. So 13, 14 and 15 by using 8:1 multiplexer. They gave one question, students. So here we do have implement this function summation of this whole by using 8:1 multiplexer. So basically what is 8:1 multiplexer consist of? It should have 8 inputs. So this 8 inputs I am mentioning like this. So this is our 8 inputs. 8:1. So this is inputs are what actually? I0, I1, I2, I3, I4, I5, I6 and I7. So now tell me how many select inputs it should have? It should have 3 select inputs. So 1, 2, 3. So S0, S1 and S2. It should have one output, right? This is a one output. We design 8:1 MUX. Next criteria. Now we need to see the mean terms. How many mean terms is there? 1 to 15. So what we'll do? We'll write down the particular truth table. So we will take particular truth table. We will take all these combinations, all 4 variable combinations. So we will write all the combinations by taking the what? By taking 8 input combinations. By taking the 8 inputs combination, I will design it. So I will take like this. I do have A, B, C and D, right? What are the combinations? I do have 0, 0, 0, 0, all zeros, 0, 0, 0, 1. Next 0, 0, 1, 0, 0, 0, 1, 1. Likewise I do have 0. Next 1, 0, 0, 0, 1, 0, 1. Next 0, 1, 1, 0 and 0, 1, 1 and 1, right? We did half. The next remaining half we will do it. We will take the remaining part of it. So this part we did. Next we are taking all remaining parts. So now we start from 1. 1, 8, directly remember like this. 1, 1, 1 and 1. So remaining same 3 combinations 0, 0, 0, 0, 0, 1. 0, 1, 0, 0, 1, 1. Next 1, 0, 0, 1, 0, 1. Next 1, 1, 0. The next is 1, 1 and 1. For 8:1 multiplexer, what we will do, students? So we will take the combination of it. We will take 2 combinations. Like this I am taking 2 combination, next 2 combination. Then I do have next 2 combination. Like this I have combined 2 bits. Right? Total these are what? 16 bits, right? So we don't want 16. We want how many? 8. That means each section we are segregating into 2 groups. 2 subgroups we are doing. So in that what we are doing? We are making this 2 subgroup. Again we are making next 2 subgroup. Next we will be making 2 subgroup here. Here we do have next subgroups, right? So next thing is that I want to write the output function. So output f. I need to note it down. How do I decide this particular f? So tell me what are these values? This is nothing but mean term m0. Next is m1, m2, m3, m4, m5, m6, m7, m8, m9, m10, 11, 12, 13, 14 and last is 15. So we do have these number of mean terms. So we mentioned all the mean terms as per the truth table. So we took these values. Next thing what we will do, we'll try to write down the values as per the given conditions. What are the values they given in the question, that we will write it down. So we will take the values, students. So we do have these particular functions. What are the functions they gave in the questions? They gave 1, 3, 4, 11, 12, 13, 14 and 15. So these values we do have. Might be it is very small, it's not visible, so I'm writing here. So 1, 3, 4, 11, 12, 13, 14 and 15. So these are my inputs values. So what I'll do it, I'll take down those values. So tell me when it is high for mean term M1. So for the first one M1 it is high. I'll did it. This part I did. Next, when it is high, 3 and 4 it is high. For 3 it is high. For 4 it is high. I've mentioned 1, 1. Next, remaining is what? 0, 0, 0. Till M5 is done. Next, 11, 12, 13, 14, 15. So we do have 11 in this particular category. 11, 12, 13, 14 and 15. So for these values it is high. So we mention high. What about the remaining? Remaining bits are 0. So it is low. So this is 0. This is 0. Again, this is 0 and this is 0. All are zeros. Now what I'm doing, I'm saying that these A, B, C, if these are my select inputs, what I'm assuming these are select inputs. So instead of these S0, S1, S2, what I'll do it, I'll assume this is my A. So I'll make the box towards it like this, I'll make it. So first thing what I'm giving this is my A select input, B select input and C select input. What about the D then? Based upon D, we will try to write down the output for it. So based upon this D value, we will write the output. So how do we write the output? Tell me students. So output is high. What is D value? This D value what I'm assuming? This is my D is nothing but my inputs. Based upon this input, my output is going to be produced. So now tell me. So when it is high, when D is equals to 1, means F is equals to D. I can write for this. For this starting two category, F is equals to D. For the second one, you tell me students. So when it is high, again F is equals to D. Tell me when it is 1, when D is also 1. For the next category, I am writing F is equals to D. For the next category, tell me when the function is output is 1, when D is equals to 0. So D is equals to 0 means for this category, I can write F is equals to D bar. Clear? So how I'm writing the output? Based upon the output function corresponding the value of D. So for output is 1 when D is equals to 1, that means F is equals to D. When it is output is 1 when D is equals to 1, that is means F is equals to D. This is the next category of subgroup, this one, this one. Next I'm writing for the next part, when output is 1 when D is equals to 0, that means F is equals to D bar. Similarly for next category there is no 1 means F is equals to 0. For the next category there is no 1, F is equals to 0. For the next category it is 1. When it is 1, when F is equals to D, right? It is 1. When it is 1, it is logic 1. This is also F is equals to 1 we can write for this. F is equals to 1 we can write. So this is the way we wrote the output. How do we wrote the output? By looking into D. So by looking into this D factor, we have decided when the output is high. When the output is high, when we had D is equals to 1, we will not see this 0 value. What we are seeing, when D is 1, what is the value of D? Either it is 0 or 1. So when D is 1 and output is 1, that means the function for these categories F is equals to D. So for that what we will do it? We will again make what? 8:1 multiplexer, we will write down those values. So for the next category, when F is equals to 1, what is the corresponding value of D? So D is also 1. That indicates for the next subgroup F is equals to D. For next part, when third category output is 1. When it is 1, when you had D value is 0. That means F is equals to D complement or D bar. Next one, it is completely 0. There is no D1 or there is no output value first of all. So that means it is nothing but F is equals to 0. For the next category, it is 0. Both are zeros. Means F is equals to 0. For the next category, there is 0. But we will not see 0. We will see 1. When it is 1, when D is also 1. That means for the next category, F is equals to D. Likewise, 2 1s, 2 1s. That means F is equals to 1, F is equals to 1. We will not see the D now. We only see the outputs because both are same. Here also both are same, right? In the previous one. That's why it is both are zeros. So we got logic high for these two category. For this one subgroups we got F is equals to 0. So this is the way we wrote it the output by taking the truth table for 8:1 multiplexer for given 4 variables. So students, so we did with the truth table. Now next criteria is that we need to design. What we need to design? we need to make these into 8:1 multiplexer. For that, what I'm doing, I'm taking one 8:1 multiplexer. Like this I took 8:1 multiplexer. So this is what 8:1 MUX or multiplexer. So for that, what I'm doing, multiplexer, right? So this I am going to design. For that, what I'm giving, what are my select inputs? How many I'll get? I'll get 3. S0, S1, S2. What is S0, S1, S2 I assume? A, B, C. What about then D? D is my input. Based upon D only, we will get the output response. So based on D, I just want to write it down, the value for it. How do I get it? So for that, what I'm doing, I'm just mentioning these are my inputs value. First thing, I0, then I1, I2, I3, I4, I5, I6 and I7, right? So how many number of output is there for multiplexer? Output is single, it is 1. Clear? So first thing, for I0, what is the values is there that I need to design it. Tell me what is first one. F is equals to D. Suppose you had the first input D, so D directly passing to this first input I0. This is your input I0. Now for the next input I1, again for I1, F is equals to D. This is my input I1. For the next input, F is equals to D conjugate. This is for I2. So what is D conjugate I'll take? I'll take one more connection. I will pass one NOT gate. So this is your D bar, right? Now I3. What is I3? It is 0. So directly I'll give logic 0 or directly I'll mention 0. For the next I4, I4 is also 0. So I can short circuit this. Like this I can write. Or I'll mention separately logic 0, no problem. You can mention both the ways. For I5, what is I5? This is your I3, I4, this is my I5. What is I5 again? It is D. So where is D connection? D is here. So I can take the connection from here. I'm passing to I5. Likewise I can go with I6. What is I6? It is logic 1. So this is my I6 connection. Likewise I do have I7. So I can short circuit this. I7 is also logic 1. So this is your I6 and I7. Now see here students, how many inputs? We had 0 to 7, 8 inputs. That is 8. How many select inputs? 3 select inputs, because it's a 2 power 3 into 1. So 2 power 3 is A, B, C. 3 select inputs. So these are what actually? These are our select inputs. So by taking the select inputs, by taking the input, single input. What is the single input? D. D is your single input. So by taking D, by taking the select input, we design 8:1 multiplexer for the given question. F is equals to sigma M of 1. 1, 3, 4, then 11, 12, 13, 14 and 15. This is your question. For that, we design 8:1 multiplexer by taking the D as input. A, B, C is our select inputs. So this is based upon these D factor. You're going to get all the input combination. So A, B, C is your select that we are not looking into it, and we are producing the output. So this is the way we can design the questions. Based upon the questions, you have to take the values of your input combinations. So by taking this way, you need to remember and you need to practice this, and you will get the answer for this particular question. So it is somewhat tilted. So see once again. So what we did, students. So we got these particular functions. We done with this particular part. We got these I0. So I0 is nothing but F is equals to D. We did with D. Next F is equals to D for the second input. So we got with D. Next I is equals to 2. I2. What is this value? It's D bar. So we connected one NOT gate. Similarly for I3, if 0, so we connected with logic 0. Likewise we had for I3, F is equals to 0. Again logic 0. Because logic 0 is there for both. Likewise for F is equals to D, we had I5. So for these D connection we took from D. Already we took D. Right? From there we took the short circuit. Likewise for I6, logic 1, for I7, logic 1. So for these question, previously it is not visible, so I am saying once again 1, 3, 4, 11, 12, 13, 14, 15. For these, this is our input. We got it for 8 inputs. Actually, previously it was how many inputs? It's 4 variable inputs. That means 0 to 15 values we modified into 8 by segregating into 2 category. Likewise, we took the select and we found the output. So this is the way we can do the problem based upon your 4:1 multiplexer. In the next class, we are going to deal with demultiplexer, reverse of it. Demultiplexer means one input, multiple outputs. How do we design it? The designing part, and how do we do some problems based upon demultiplexer and all that particular thing we will see in the next class. For today's class, practice the questions which I have solved in today's class, the 4:1 and 8:1 multiplexer. Try to take the questions by your own. You try to take the numbers by your own and try to solve it. If you are getting any query, you can mail me. I just give my mail ID in the description of the video so that it will be easy for you to understand this thing. Thank you. Thank you very much for today's class. Have a good day.